Alright, so what we're doing today, we're going to try something a little bit different. We're going to do this by videos, and so you can go and look at this anytime you want to. So what we're looking at today, Standard 2 says this: the students will explore the nature of matter and its classifications and its system for naming types of matter. So what we're looking at today is how can we classify the different types of matter. Alright, so first off, we got to know what matter is. So if we look at matter, matter is anything you can see, touch, or taste, feel. And the scientific definition is this: says that matter is a substance that has mass and takes up space. So you're sitting on a piece of matter right now. You're most likely using a piece of matter right now with your pencil. Everywhere you look in this classroom that you're at, or in the room you're at, you're looking at matter. So matter makes up most everything we can see. All right. So now we're looking at there's two main types of matter. That's what we call a pure substance and a mixture. And the main thing you need to know about a pure substance and a mixture is that a pure substance is what they call chemically combined. This means there is a formula. Just say H2O. That is a formula that is chemically combined by these bonds. We have these bonds right here and here. These bonds right here and here are the ones that make H2O. And so if they're chemically bonded, we know that's what we call a pure substance. Okay? So we have chemically bonded, and then we also have what we call physically combined or physically bonded. And all that means for physically bonded is that it can be separated. The main difference between a mixture and a substance is that we can separate a mixture, but we cannot separate a pure substance. We cannot separate those. Okay? So let's look at a pure substance and see what those contain. Okay? So first of all, a pure substance is made up of two parts. We have what they call an element and a compound. We already studied about both of these. Main thing about element is that they found on the periodic table. Like here, carbon, atomic number 6. It's an element. Fluorine, atomic number is 8, 9. Atomic number is 9. Found on the periodic table. Hydrogen, which is found on the periodic table as well. So if anything is found on the periodic table, then it is a pure substance. Okay. And we also have what's a compound. That's made up of two or more elements and is chemically bonded together. Like right here, we have hydrochloric acid, H2O, which is water, and we have sugar, glucose, which is C6H12O6. That is a compound. It has to be. It's chemically bonded. It's a big thing. All right, element's just one by itself, and we. Dang bell. Alright, so elements bonded is by itself, standing alone. Carbon by itself is an element. Fluorine by itself is an element. Hydrogen by itself is an element. But if we were bond with something, just like our Cl and our H, when we bond with something, that is what we call a compound. Okay. All right. Element versus compound. Elements by itself, one found in the periodic table, and then compound is two or more of these elements found in the periodic table, and they're chemically bonded together. All right. Then we have the other part, what we said was mixtures. So we have pure substances, and now we have mixtures. All right. So a mixture is a homogeneous mixture, or it could be a heterogeneous mixture, either one. So if we're looking at a homogeneous mixture, as particles in a uniform manner, all that means is that they all look the same. A good example of this would be sweet tea. If you look at sweet tea without the ice in there, they all look the same. Coke would be a good example. If you're looking at it, air, as you see right here, you can't see the different particles of air, but we know that nitrogen, hydrogen, oxygen, all those different things make up air. So we can't see it because it's a uniform mixture, a uniform manner. All right, that's homogeneous. That homogeneous means the same. All right, so all the parts are going to look the same. In a heterogeneous mixture, that means different. So that means we can tell out the different particles, and that definition is particles that are not spread in a uniform manner. Good examples of this would be pizza, salad, gravel. Anything you can see the differences. Wood would be a good example. Anything you can think of that you can tell the different parts will be a heterogeneous mixture. Okay, so to bring that all back together, this is what your note should look like. We have matter, which is the amount of mass that makes up a substance. It has volume and takes up space. And then we have what's a pure substance, and we have a mixture to be as two second categories, main groups. Pure substance is broken down to an element and a compound. The elements are found on the periodic table. They're made up of anything we see on the periodic table. These are just some examples: carbon, phosphorus, chlorine, fluorine. When we bind these things together to make to another element, we call them compounds, which is two or more elements chemically combined. Salt would be a compound, NaCl, H2O, which is water, and then SO4, and that's our sulfate. And that is the difference between pure substance and element. A pure substance was we have the element and we have the compound. Elements found on the periodic table, singular, compounds two or more. Okay. Then we jump over here to the mixtures. We have homogeneous and heterogeneous. Homogeneous is spread evenly throughout. Also call them solutions that we studied. You made your parodies about. Tea, Coke, and air would be good examples of that. And then a heterogeneous mixture, that's the substances mixed that are not uniformed. They look different: salad, pizza, wood, and gravel. And that is our notes for matter and how do we classify them. Okay. If you want to go back and replay this many times you want to, you can. Hopefully this helped.